All right, section 9.5, getting into the Pythagorean theorem, right, which is a geometry concept, but we use some algebra to solve for missing sides. Okay, now the Pythagorean theorem is very useful. It's based upon right triangles, right? So in building, I know when I was building my first house to check to make sure that I made my walls square, so the corners were 90 degrees, I used Pythagorean theorem to check that out. Um, so our learning targets today, we're going to be able to use them on right triangles to find missing side lengths, right? And it says if it's a right triangle, then Pythagorean's theorem works, and we'll look at to see what Pythagorean's theorem is in a minute here. And then the term converse, that just means the reverse of that. The converse of the Pythagorean theorem, we're going to use that to determine if it's a right triangle. So meaning if Pythagorean's theorem checks out and works for the side lengths, then we can say it's a right triangle, right? And we'll look at that in day 2 of our lesson. So, some key terms, right? When we refer to triangle, a right triangle specifically, there's 3 sides. 2 of them we call legs, and 1 of them we call the hypotenuse, right? So the legs are the sides that make up the right angle. So if I look here, this is a leg, and this is a leg, and they form this right angle right here. The hypotenuse is what closes the right angle, right? It's always across from it. And it's always going to be the longest side because 90 degrees is the biggest angle and it closes that. So it's the longest side. Meaning, if I took this leg and I turned it over here, right, what happens to this, right? The angle gets bigger, but then the side required to close it also gets bigger. So I know that that's going to be the longest side because 90 degrees is always going to be the largest angle in a triangle if you have a right triangle, right? Meaning we only have 180 degrees total, so these two have to be less than 90 degrees. So an easy way to identify the hypotenuse is if you draw this right angle and then you make it an arrow, it points to the hypotenuse, right? The other two we call legs. They're not the same length. They could be, but they're not always the same length. All right, but we just call them both legs and we identify one of them with a variable a, the other one b. Hypotenuse we use as c, and you'll see why that's important when we look at the Pythagorean theorem. Okay, Pythagorean theorem gives me the relationship between the legs and a hypotenuse on a right triangle. That's very important. This theorem works on a right triangle. So uh, you can see that it's a squared plus b squared equals c squared, right? So when I square the legs and add them together, it's equal to the hypotenuse squared. So, quick example. So I want to identify the hypotenuse first. So if I draw my 90 degrees, it's pointing right here. So this is going to be C. All right. Now going into this problem, I should be able to identify a relative size for C, right? I know that it's going to be the longest, so it has to be bigger than the 2 legs. It's going to be bigger than 3 and 4. Now, I just need to call the legs, one of them A, one of them B, and it does not matter. Typically, they pick the smaller one for A and the larger one for B, but you could do either or, it does not matter. So I'm going to plug in A here, right? So that would be 3 squared plus, and then I'm going to plug in B squared equals, and this is what I'm trying to find, C squared. So if we think about order of operations, right, a typical mistake would be to say, all right, this is 7 squared, and that's not true. Order of operations says parentheses, none there, exponents next. So I have to do these exponents, right? 3 squared is 9, 4 squared is 16, equals C squared. So 9 plus 16, that gives me 25 equals C squared. Now, this side length is not 25. All right. And really, we know that it has to be less than 7. And here's why, right? So it has to be bigger than 4, right? It has to be greater than 4 and less than 7. So there's my range of values that I'm looking for. And here's why it has to be less than 7. Think about a race, right? If I'm racing from here to here, the shortest distance is going to be going straight from point to point, right? So this distance here has to be shorter than going around about, right? 4 and 3. That would be a longer path. So I know that this hypotenuse has to be bigger than 4 because it's the longest, but it has to be less than 7 because it's a shorter route than taking the outside legs on a triangle to get there. So we have to remember back to 9192 when we talked about square roots, right, to solve, right? So if I square root both sides, I get 5 equals c, right? Because a square root cancels out a square. Now, just to um, not confuse you too much, but just remember when I square root here, I could also get -5. That's an actual answer. However, in the context of the problem, -5 wouldn't make sense as a side length because that's what we're trying to find. If I were just solving this equation not for a triangle, I would have to have 5 and -5. But today we're looking at lengths of a triangle, so that does not make sense as an answer. I'm only looking for the positive value, which is 5. All right, so let's look at some examples where we're finding the hypotenuse, right? So again, I take my right angle. All right, sorry about that. I had somebody join my Google Meet there. So let's identify the hypotenuse, right? So it points at it. So this is going to be C. Let's call this A and this B, right? So if we use Pythagorean's theorem, right? And let's write that down just to make sure. A squared plus B squared equals C squared. So I'm going to say 4 squared plus 8 squared equals my hypotenuse squared, right? Remember, we got to do the squaring first. So that would be 16. 8 squared is 64. That's equal to C squared. So 16 plus 64 give me 80. Now, I know this isn't going to be a perfect square because 81 is equal to 9, right? Square root of that is equal to 9. So I know it's going to be 8 point something, probably close to 8.9. So if I square root 80, I get 8.944. We'll just go to the nearest tenth. So we get 8.9 equals C. So this is 8.9, right? And if we look to see if that makes sense, right? It's bigger than 8, but if I were to go from here to here, that has to be shorter than 4 plus 8, which is 12. So that makes sense as my answer, right? In all of these examples, we are going to be looking for the hypotenuse. Okay, so I want you to pause the video here and see if you can solve for C, right, using Pythagorean's theorem. Okay, solve for C. Pause and check back. All right, let's see how you did, right? So the example over here, right, you had 3 and 6, so 3 squared and 6 squared. You end up with square root of 45, which is about 6.7. Over here, you had 7 and 10 as your leg, so squared 149, which is about 12.2. And then here you had 3 and 7 for your legs, so 9 plus 49 was 58, right? And so when we square root 58, we get 7.6. All right, so finding a missing leg, right? Meaning we have the hypotenuse, we have another leg, we're going to find the missing other leg. All right, so to do that, remember it's going to be smaller than the hypotenuse. Okay, it's going to be smaller than the hypotenuse. And here's my Pythagorean theorem, right? If I want to solve, and let me go over here so you can see where these come from. right? So if I have a squared plus b squared equals c squared, right? And I want to solve for a, right? I could plug the values in, and I'll show you both ways, and you can decide. But if I want to solve for a, right, to get that, I would have to subtract b squared from both sides, right? And so I'd end up with a squared equals c squared minus b squared. So using Pythagorean's theorem to find a leg, we take the hypotenuse squared, subtract the leg squared, and we get the other missing leg. So let me show you this example here. And again, it does not matter what you call leg A and leg B, right? Let's just say, well, this is A, this is B. C is the only one that's important, right? C is the one we have to have as the hypotenuse. So if we look at our Pythagorean theorem, okay, and we can plug these values in, right? So we said A is 12, B is what we're trying to find, and C is 13. So 12 squared is 144. 13 squared is 169. If I subtract 144 from both sides, we get b squared equals 25, right? Now, 25, again, that doesn't make sense because it has to be less than the hypotenuse 13. We have to remember our last step, which is square rooting, and we get b equals 5, right? So b equals 5. Now, you can use that all the time, whether you're finding a leg or a hypotenuse. This is just kind of the shortcut where it goes from this to one of these, right? So I could say in this example, c squared, 13 squared, and I'm subtracting a squared, right? Subtracting because I need my leg to be smaller, right? So this would be 169 minus 144 equals b squared, right? Again, we get 25 equals b squared. When we square root, we still get 5, right? So this is kind of just a shortcut when you're solving for a leg of having to subtract in the middle of your problem. If you just plug it in like this, your variable that you're solving for is already isolated. But you can choose which way you want to do that. So let's look at a couple examples here, right? Again, identify the hypotenuse. So there's C. That means I'm solving for A or B. It doesn't matter. Let's call this A. Let's call this B. So I'm going to take, since I want the smaller, right, I'm not going to add these squares together. I'm going to subtract, right? I'm taking my hypotenuse squared minus leg squared, and that's going to equal, you can call it whatever you want, x squared, b squared, doesn't matter the variable that you use. So when we do 15 squared, we get 225 minus 13 squared, which was 169, and we get, right, we're solving for our side length, we get 56 equals x squared, right? Last step, we have to remember to square root, right? 56 is not a perfect square, right? It's bigger than 49, less than 64, so it's going to be in between 7 and 8, right? And if we take the square root of 56, we get 7.48. We'll round that to 7.5. All right. So I want you to take a minute and see if you can solve for a missing leg, right? We know it's a leg because hypotenuse is right here, right? So we can call this A, this B, and then use Pythagorean's theorem to solve, and then check back with your work. All right, should have gotten 14.1 as your answer, right? Since I'm looking for a leg, we're going to use subtraction, right, instead of addition, right? When we're finding hypotenuse, we add a because we want it to be the bigger side. When we're finding a leg, we have to subtract those values to get the smaller leg. All right, I want you to take a minute and see if you are finding the hypotenuse or if you're finding a leg in the first and second example, right? So identify A, B, and C on your triangle. All right, in the first one, our missing side is the hypotenuse, so that's going to be C, right? And this one, right, and then we can just call A and B. In this one, here's the hypotenuse. We'll call this one A, this one B. Remember, the legs, the ones you call A and B, don't matter. You have to identify C correctly, right? So if I'm looking for the hypotenuse, this is the longer side. So I'm going to take 2.7 squared plus, right, because I want it to be bigger, 6.5 squared, right? We'll solve that in just a second. Here, I'm looking for the leg, which is smaller. So I'm going to take the hypotenuse, the longest side, and subtract the leg squared, right? So if we take a minute and solve this, right, the first one, 2.7 squared plus 6.5 squared, we get 49.54. And we have to remember to square root as our last step. So if I square root that, I know it's going to be really close to 7, right? And it's 7.03, but to know that it's not exactly 7, we would write our answer as 7.0 because we rounded that to the nearest tenth, right? It's not just 7 even, it's 7.0384, blah, 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 but we rounded it to the nearest tenth, which is 7.0. In our second one, if we did 9.9 squared minus 6.5 squared, we should get 91.51, right? And then we have to remember to square root, right? Remember, 100 is 10, so it's going to be less than 10, but bigger than 9. So when I square root 91.51, we get 9.566, so it's going to be 9.6. Right, so if we look here, 9.6, right, makes sense. It's smaller than the hypotenuse. Looking over here, 7 is the longest, that is the hypotenuse. All right, so I want you to practice these problems just using the Pythagorean theorem. Be careful, make sure you identify whether you're finding a hypotenuse or a leg. All right, I hope you have a great day, and we'll talk to you soon.